When you hear artificial intelligence, you might think of science fiction, right? But the thing is, its creation story is happening as we speak. And if you really want to understand where AI is going, you first have to understand where it was born, the places where it was tested, pushed to its limits, and finally proven. Today, that's what we're going to do. We're going to explore that history, not through some dry textbook, but through something you might not expect, the world of games.
And look, let's be absolutely clear about this. The shift we are living through right now is monumental. It's the kind of turning point in history that only comes around maybe once every 500 years. Seriously, this isn't just a new gadget or app. This is on the scale of the Renaissance, the discovery of electricity, or the invention of the printing press. The very ground is shifting under our feet.
And this new era, it has a name. We're living in the age of artificial intelligence. And it's not some passing fad. It's the engine that's already reshaping our world, from our economies all the way down to how we think about what it even means to be human.
So where did this revolutionary force learn to think, to strategize, and even to create? Well, it wasn't cooked up in some sterile laboratory or a top-secret government project. No, AI's most important training ground, its real crucible, well, that might just surprise you.
So why games? What's so special about them?
Well, think about it. They're the perfect laboratory. You've got a closed system, a clear set of rules, and a single measurable goal: win. That makes them the absolute ideal environment to forge and test the very limits of what a machine intelligence can do. Our story really kicks off with the first great public showdown between machine and man, a battle of pure, cold logic that suddenly put AI on the world stage for everyone to see.
The year is 1997. The whole world is watching as the reigning world chess champion, the legend himself, Garry Kasparov, sits down to face a totally new kind of opponent. It isn't made of flesh and blood. It's made of silicon and circuits. It's IBM's supercomputer, Deep Blue.
You know, this was a true clash of titans, a clash of two totally different kinds of minds. On one side, you have Kasparov, a human grandmaster running on decades of experience, on pattern recognition, on that gut feeling we call intuition. And on the other side, you have the machine. Deep Blue couldn't feel the flow of the game, not at all. But its weapon was just this computational sledgehammer of raw, brute force calculation.
And what do we mean by brute force? We mean it was evaluating 200 million possible chess positions every single second. Deep Blue wasn't playing with hunches. It was just overwhelming the game with pure mathematics, calculating endless possible futures to find the single best move.
Now, let's be really clear here. This was a victory of its programming, of its algorithm, not a victory of true learning or intelligence. Deep Blue is basically told the rules of chess and then just told to calculate. It didn't understand the game like Kasparov did, but the symbolism, my God, the symbolism was huge. For centuries, chess was seen as the peak of human intellect, and a machine had just climbed to the top. The public definitely took notice. Okay, so the machine had conquered pure logic. Check. But could it ever get a handle on something far, far messier? Something built on nuance and subtext and context? Could an AI actually conquer the beautiful, illogical chaos of human language? This next mountain was a whole lot steeper than the 64 squares of a chessboard.
So the next great frontier was language. It's this messy, fluid thing where context is absolutely everything. And cracking that code, that was going to require a whole new kind of AI.
The field is called natural language processing. And its ultimate public test, its Super Bowl, came in 2011. IBM was back, this time with a system named Watson. And Watson wasn't playing a board game. Its challenge was to win on the quiz show Jeopardy! A game that's all about riddles, puns, and clever, tricky wordplay.
And what makes this so incredibly hard is that our language is just a beautiful mess, isn't it? Think about sarcasm. When you say, "Great, I missed my flight," you mean the exact opposite of what the words say. Or irony, or how the word sick can mean you're ill, or it can mean something is awesome. Or idioms, break a leg. For a machine that thinks in ones and zeros, this stuff is a total labyrinth. To even stand a chance, Watson had to learn how to navigate all that ambiguity.
And it worked. Watson's victory was a massive moment. If Deep Blue's win was all about calculation, this win was about comprehension. It was the proof that an AI could finally navigate the subtle, shifting, often illogical currents of how we actually talk to each other.
So AI had conquered logic, and it had cracked the language code. But could it tackle something that feels even more uniquely human? Could a machine actually develop something like intuition? Could it go beyond just understanding what already exists and start creating something new in a game so vast that calculation is impossible?
This brings us to the next great test, the ancient game of Go. A game so mind-bendingly complex, many people thought a machine could never, ever master it. Just to give you a little perspective on what complex means here, the number of possible positions on a Go board is 10 to the 170th power. That is a number so big, it is larger than the number of known atoms in the entire universe. You cannot win this game by calculating every move. The universe itself isn't big enough for that.
And this is so important. Remember that brute force sledgehammer that Deep Blue used for chess? Well, in the cosmic ocean of Go's possibilities, that strategy is completely, utterly useless. To win here, you can't just calculate. You need to have a feel for the game. You need something that looks an awful lot like human intuition.
So in 2016, DeepMind's AlphaGo sat down to play the Go legend Lee Sedol. Now, AlphaGo started by studying millions of human games, sure. But then it played against itself millions and millions of times, essentially teaching itself through endless trial and error. And the result was revolutionary. AlphaGo didn't just learn our strategies, it started creating its own. It was making moves that human commentators called creative, even beautiful. It wasn't just playing the game anymore, it was redefining it, and it won.
All right, so logic, check. Language, check. Intuition, check. But every single challenge we've talked about so far, chess, Jeopardy, Go, they all shared one common feature: perfect information. Everybody could see the whole board. So what happens when you take that away? Could an AI possibly win when critical information is hidden from it?
This brings us to what might be the most realistic challenge of all: dealing with imperfect information. This is where winning requires adaptation, making educated guesses, and even deception. I mean, just look at the leap we're talking about. On one hand, you've got games like chess and Go. The information is perfect and complete. The environment is static. It's turn-based. Winning is all about pure strategy. But then you look at games like poker or StarCraft. The information is totally incomplete. You have no idea what cards your opponent is holding or where their army is. The environment is dynamic and happening in real time. All of a sudden, the skill you need isn't just strategy. It's adaptation. It's deception. It's bluffing.
And wouldn't you know it, by 2017, AI mastered this too. An AI named Libratus beat some of the world's top poker pros because it literally learned how to bluff, how to strategically win even with hidden information. That same year, another AI, AlphaStar, reached the highest human rank in StarCraft, mastering insane real-time strategy and multitasking, all while adapting to an enemy it couldn't fully see.
So, why does any of this matter? Who cares if a computer can win at StarCraft? Well, because the skills that AI learned inside these games, they're the exact same skills we need to solve some of our most complex real-world problems.
The connection here is so direct. You take the game challenge, managing an economy and army in StarCraft, the skill the AI has to learn is rapid optimization and multitasking in a constantly changing environment. And the real-world application? Well, that's managing a global supply chain, or predicting when a factory machine will break down, or detecting a sophisticated cyber attack in real time. The path from the game to reality is crystal clear.
So just think about that journey for a second. From the cold, hard logic of Deep Blue, to the language comprehension of Watson, to the creative, almost beautiful intuition of AlphaGo, and finally to the adaptive, real-time decision-making of AlphaStar. These aren't just skills for winning games. These are the literal building blocks for the AI that is already starting to optimize our world and build our future.
And all of this, it leads us to one final incredibly powerful question. For decades, we challenged AI to beat us at our own games. Step by step, we trained it to master our most complex creations. Now that it can,
What's next? What happens when we turn this incredible intelligence away from our games and point it towards the grand challenges that we as humans can't seem to solve ourselves? The real game, you see, is just beginning.